All right, we're going to kick this off now. Let me find my slides. Great. Thank you, everyone, for joining. We really appreciate it. We love doing these demo days, and it also feels really good when all of you show up. So we'll keep on doing them as long as you come, and try to keep them interesting and exciting. Today's demo is going to be around two things. The primary one is we shipped a rather large feature recently around building cost analysis into Stategraph. So we'll show what that looks like and all the features around it there. And then also we want to help everyone understand exactly how Stategraph works and what it's doing. And so we decided to start doing some more technical deep dives on certain functionality within it. So the one we're going to do today is cross-state transactions. If that doesn't make sense, that's fine. We'll get there. But this is one of the features that I think really makes Stategraph unique. And nobody else is doing anything like this in the IAC world. So we're pretty excited about that. Before we get to the demo, though, I want to do a little housekeeping. One of them is the changelog. We have not been sitting around doing nothing since the most recent demo, since the previous demo day. Main thing to highlight here is we released Stategraph Cloud, which is our SaaS offering. Now, generally, we recommend people do self-hosted Stategraph. It's just sort of, you can have secrets in there, and we want you to be in control of your state. Like, that's what's important to us, is that you feel in control of anything, any sensitive values. But if you don't want to run more infrastructure, you can always use Stategraph Cloud. We've also been shipping lots and lots of other features from big and small, security scanning, cost, and many performance improvements and bug fixes. So we've been really trying to release as fast as we can here. And a little taste of what's coming up in the future is we have session capabilities, which is adding a whole new security layer to the IAC world. So in this case, you'll be able to, for example, create a token which allows users to, whether human or AI or any machine or anything like that, to be able to operate on certain states or resources. You can limit what resources they can modify. So a great use case we have internally is that sometimes we want to let Claude modify infrastructure, but we want to make sure that it doesn't actually apply any of those changes. We want to do it in a fast feedback loop locally. So we create this token that only lets it plan changes, and it can never apply changes. And now you know that you're safe going very aggressive on modifying and making infrastructure changes, even with an agent. The other feature coming up soon that we want to talk about, and we're very excited to have a demo on this once we get there, is Terragrunt support. So we have focused very heavily on being backwards compatible with Terraform, trying to make that switching cost as close to zero as possible. And Terragrunt solves a lot of the same challenges that Stategraph solves, but we think Stategraph does it in a much better way. But we also don't want people to have to refactor out of Terragrunt to start using Stategraph. So we want as close to zero switching costs from Terragrunt to Stategraph as well. So those are some upcoming features we're pretty excited about. If you've come to these previous demo days before, you know we always start with the goals. And our goals are to manage all of your infrastructure as one unit, provide insights into your infrastructure, and blazing fast plan and applies. If you've been paying really close attention to previous demo days, you'll notice the ordering of this is a bit different. We used to start with blazing fast plan and applies. And in talking to people, we've sort of realized that while fast plan and applies are really important to users, it's really what that unlocks that is the consequence of being able to do that is really valuable to people. And the consequence there is you no longer have to either physically encode or mentally shard your infrastructure across all of these different modules. You can treat it all as one unit. And as a user of Stategraph, you won't really notice a difference by this reordering, but I think, yeah, I just want to highlight it because it accents how we're thinking differently about what the value we're bringing to people is. So being able to manage all your infrastructure as one unit is really important to us. And we're going to see in this demo what some of that means. And how do we do all this? Just a little technical background here is, so we take Stategraph takes your code, HCL code, and your Terraform state, and it imports it into the database in a denormalized fashion. So we don't just take that state file and put it as a blob, and we don't just take your code and put it in as a string. We're actually breaking up all of this into like each individual rows inside meaningful tables. So for example, output's going to an output table and everything's connected to a state. So by breaking all of your infrastructure up and all of your state into a normal SQL denormalized structure, that unlocks all of these abilities that Stategraph can now do. And one of them is going to be cost. One misconception I want to clear up though is that many people think initially that Stategraph is a state backend for Terraform. And it's not, because you can't actually do all the things we're doing purely in the state background, a state backend. Stategraph is actually the engine running your Terraform code. And obviously it's entirely backwards compatible with existing providers and everything. But it is actually like it's a new evaluation engine, and it has to be in order to unlock all of the possibilities that we're able to unlock. That's how we can operate, not on your entire code base, but on only the subset that is impacted by the change that you're making. And that's what unlocks all these speed improvements and all these other things. So it's more than just a backend. All right, let's get to cost. So I'm going to start in, one sec here, in the UI. This is the home screen, as you're probably used to. And once you scroll down on the left here, you will see a new section called cost. And there's a bunch of subsections here. Overview gives you just a high-level view across all of your states, how much you're spending, kind of like the standard normal things you'd expect to see here, all rolled up into one view. It's useful if you want a quick glance at anything. In my opinion, the really valuable page, though, is analysis. This lets you pick which state you actually want to go deep on and see everything about that state, and be able to see what down to the resource level and the instance level within a resource. As you can see, we have a for each here on a bunch of web nodes. You can see what each individual resource is costing you. And not only that, but it's very important to point out here that this is not just the cost estimate, which we do on a plan, and we estimate the cost of your state as well periodically. But you also get actuals. So by using the backend, the APIs provided by various cloud providers, we can get how much it actually cost you to run those resources, and then we can correlate those things. So not only do you get the estimate on every plan and operation, but you also get what the actual value is at the end of the month. So you can make sure what you're estimating matches what you're actually spending. And that's really valuable just to, to know. It's good to reconcile these things at the end of the month, because it's not always trivial to estimate what something might cost, especially when things are charged by request or something that depends on the number of users actually interacting with your resource. So you get both views in this. What unlocks this is the fact that as we going back to the previous slides, all of the state is in the database, and actually we don't have to do much to actually get access to all of the state across your infrastructure, of course, because it's all there. And then we periodically just perform cost analysis on it. We can do it on any operation because it's all there. The centralization of that means that all operations in Stategraph go through Stategraph. And if you turn on a cost policy or similar, all operations get that applied to it. So there's no way for someone to do a change outside of Stategraph and then thus bypass any sort of cost check or anything like that. Now, speaking of cost checks, we have budgets. So you can set up rules around states and what behavior you want if that budget is violated. So for example, you can have just a user gets a warning, or they are actually blocked from performing an apply based on a cost change. So you have all this functionality around governance and policy here. And then policy also lets you apply other rules to changes as well. So what's this look like when you're actually using Stategraph? Let's see. Share my screen. So I have just a simple checkout here. There's a bunch of scripts here to sort of make my life a little bit easier to show you what's going on. But it's a main file with a bunch of resources in it. And this is actually the same state that we were just looking at in the UI. So I'm going to run a plan and make sure that it shows the guardrails, which of course corresponds to the budget we saw. So I'll kick this off. Stategraph is doing its work on the back end here, making sure to run our changes. This might take a few seconds. And a big output here. Now, I want to point out a few things. One is this part. I know it's hard to see because I created a bunch of resources to try to show a large cost change. But this is the Terraform output you should be familiar with, where you're just getting your resources, what's changed, so on. But since Stategraph is the entire engine here, like we pointed out, we aren't restricted in what we can show in the plan. We can actually show anything we want. So we've co-located cost information with your plan as well. So here is where a Terraform plan or a Tofu plan would end. And then now you also get the cost breakdown for this particular change in the same output. So everything is there. You can also change the format it looks in if you want to consume it through scripts or anything like that, but you get everything there. Now, we saw before that we had a budget associated with this state. So you can see at the end here that we have a budget. Our guardrail says that we're over budget and how much, what the limit is, and so on. So inside of your plan, no matter if you're working on your laptop or in CI/CD, you get to see the output of the entire footprint of what you're changing from cost to security to your actual plan. Now, the other thing I want to show is that it's very important to us that you get access to the data that we have inside Stategraph. We have very permissive APIs, and they're go through a capability system, so you can restrict who can see what, but you can run SQL against Stategraph that is validated against what the user is capable of performing. And so that means you can get access to everything that we do store in the database that we expose through this API, which is not the entire database, but a subset of what we want to show. And we have included cost in that as well. So here we have a command line query, which is going to output in JSON, so it's easy to consume through other tools. And all this is going to do is for my production and staging environments, roll up the cost and show me some monthly and annual information. So let's run this. And so you can see here, JSON output, exactly what we wanted. So it's easy for you to integrate any other tooling you have, if Stategraph doesn't implement something that you want, you can hit it through an API to be able to extract the data that you want to show and build out things yourself as well. So we want to be a good player in this world, like very composable Unix philosophy. You can integrate against Stategraph in many ways. Okay, so that's cost. Now, I know that's a lot, but let's jump into the next thing, which is cross-state transactions. So what is a cross-state transaction? Well, I have an example repo here. In this repository, we have two root modules, network and app, and we're actually simulating everything using Terraform data resources, just because we want to make it simple and easy to understand, and it doesn't matter what resources you have to show what we're trying to express here. So the network just has a few resources, and then we have a few outputs related to like a VPC, have something like that. The app one here, what's interesting is it depends on the network root module through a Terraform remote state. And it uses those outputs to make decisions internally. So we have a dependency between these two root modules. Now, Stategraph is integrated with our orchestration product, our open source orchestration product called TerraTeam. So we made a change and ran it through Stategraph using TerraTeam here. So you can see it inside a proper GitOps flow. So let's see the change. Well, we just made a simple change to one of our subnets here. And when we look at the plan, and this plan mostly looks just like standard Terraform plan, but you'll see a difference up top. We have this legend here indicating that multiple states were involved in this operation. And when you scroll down, you see state 1 is the network state that we modified, the root module we modified, and we can see that in the plan output as you'd expect. But we also have this other state, the app one, that is dependent on the outputs that we change in the network state. And we can actually see that in this plan as well. So traditionally, you would have to plan and apply your network root module, and then you can finally plan your app root module to see what the impact is there. But because Stategraph lets you operate across your infrastructure as one single unit, you see the entire blast radius in a single plan operation, and you can actually apply it in a single apply operation. So you get to see exactly everything that you're changing, all the consequences of this one change. So if you imagine an example where you have a database that you decide you want to delete, and you have downstream root modules that actually depend on it, you'd be able to see that in a single operation rather than deleting it and then going to plan the later root modules and realize, whoops, I don't actually have a database anymore or anything like that. So that's what a cross-state transaction looks like. Now, how does it actually work? So we have, this is the setup that we just showed. We have state A, state B. So state A would be network in the previous case, and state B would be app. Now, when you do a plan or an import or anything like that, when you pull your data into Stategraph, we have a detection step where we look at Terraform remote states, and we can connect that remote state to the remote state as it exists in our database. And then we add some metadata around your state indicating the other states that it depends on. So in the database now, we have this connection between all of your dependencies, even cross-state dependencies. Now you make a change in state A. We construct an application level transaction. So we seed that transaction with our change. In this case, it's to a database. And then we do a blast operation across that. And we see, okay, if we start with this seed, what are all of the nodes that are impacted by that? And we pull them into the transaction. And then this is where the real magic happens. So this is not exactly what we do. This is a conceptual way to think about it and look at it. We're actually reconstructing a new root module where we have taken state A and state B and rewritten them now as child modules. And the outputs and inputs across these, we connect as normal child modules, outputs and inputs. And then we can just run it inside of Terraform or Tofu as a normal root module. This is how everything is connected. This is how you can now take things that on paper are completely separate and run them now as one unit. And the and with all the inputs and outputs connecting just as you would expect. Now we have to do a bunch of paperwork here on the database side and the server side to make sure we translate things back and forth to what you as a human expect. But conceptually, you can think about it in terms of we're dynamically sizing your code, your state, and dynamically constructing your root modules on the fly in a per operation way that lets us connect all of your infrastructure as one unit, and also only the pieces of your infrastructure that are relevant for that one change. So in the Stategraph world, there's no real distinction between a child module and a state anymore. All of these are just rows in the database as far as we're concerned, and we can incorporate them or exclude them from an operation as we wish. So with that, if you're interested in upgrading your Terraform, you can book a demo with us, or you can fire up Stategraph Cloud and start playing around with it. Thank you very much. Are there any questions or comments? First question around in AWS context, are your budgets proper to Stategraph, or can they be associated with AWS budgets? Right now, they are part of Stategraph because we integrate against multiple cloud vendors, and so, but certainly that's an integration that could happen. Oh, Josh already answered that. Sorry.
I have a question, if I can ask instead of writing. So when you demonstrated, I forgot how you call it, it's like cross dependencies or something, where you have Terraform plan output, which looks like normal output, but you added some extra things there. Is it possible to get this output as JSON, like normal JSON Terraform plan JSON file?
Yep, so we have Stategraph show-JSON, just like normal Terraform as well.
But how do you expand extra information there? Because the schema, official schema, is rather limited.
Yeah, so we try to be compatible there. Right now, we try to stay within the bounds of that schema. So you do get sort of like your resource names sort of get rewritten a bit to include some state identifiers in there that you can then use if you want to process that JSON yourself, it's consistent across the entire output. So at least you can like consistently pull it apart to show it how you want. But we don't have a bespoke like format for that currently, because we want to stay consistent with other tools as well.
Yeah, and that's what I'm asking, because the information which you showed at the end about prices and budget, how can I get this information from the state, like from the plan file? Because of the official Terraform schema does not have room for like extra fields, right?
Yeah. So in that case, we're actually sort of combining multiple API calls to show that output. It's not necessarily like a concrete plan file. The plan file that Stategraph actually creates is that so you create a plan file, just like in Terraform, you have a plan file out parameter, but in the Stategraph world, that's actually just a bunch of database references, so it knows how to go find that data again. But all of that data is exposed through APIs, so you can always use a Stategraph CLI to collect it locally and then ship it someplace if you want. But it's more than just a normal Terraform plan file.
Yeah, exactly. So it's like it has intention to be backward compatible and fully supported, but you still have extra API calls which you have to do to extend this provided limited schema. Okay, yeah.
Yeah. We try to stay as close to conceptually backwards compatible with Terraform and Tofu as possible. And then always, the CLI is always using the same APIs that any user would use as well. So we try not to lock away anything behind some sort of format that's not clear or anything like that. So at least like conceptually, it should feel the same to everyone. And there's differences underneath, of course, but all those differences, if you say, okay, am I in a Stategraph environment? You can at least access everything that we do differently in like a structured format to operate on it.
Mm-hmm. Yeah. Well, very good. I like what I see. Thank you very much.
Thank you very much. Question from James. Terraform is supposed to be more of a declarative infrastructure tool, so why do we get so hung up with getting it to desired state when the tool is supposed to see what you're trying to declare and what the current state is, even if the state isn't there already? Terraform by itself seems to have lifecycle rules that you want to destroy first if it can't match up. Does Stategraph deal with that differently? Stategraph does not deal with that differently. We are trying to be backwards compatible with Terraform. And the reality is that, yes, we want to be declarative, but cloud APIs don't necessarily always play well in a declarative world. And it's not just cloud like AWS or GCP or anything like that. If you're managing, you can manage PagerDuty, anything with an API through Terraform, and not all these things play well. In particular, my understanding is like Azure requires a bunch of lifecycle management declarations depending on what you're doing. So we're trying to be backwards compatible with Terraform. We do the same lifecycle things as well. We are trying to set a foundation, though, where we can start saying, okay, now that we are backwards compatible, how can we start doing things in a better way? So we're still working on getting to this point with a lot of our core engine support. We're already doing that with security and RBAC and cost, trying to do things better. But when it comes to the core engine, we still aren't there at the point where we feel comfortable that we want to try like breaking away and doing our own thing, where we think that keeping people's mental model and understanding, reducing the shift they have to make mentally to start using Stategraph from Terraform is more important to us now than trying to fix some of these things that we agree that Terraform doesn't necessarily do best given its claimed goals of being declarative.
Hey, Malcolm. I don't know if there's any others, but if I have a question, if you...
Yeah, go for it.
So I was just curious. So typically, and maybe it's kind of related to the previous question, but this is my first time joining, so I'm kind of just catching up on what it all does. So it's
well, welcome.
Thank you. It's not exactly on the features you discussed, but I was kind of curious on, in the sense of like, so typically when you run a plan, you get a refresh state. Now that refresh state, it detects drift, and in this case, from what I kind of understood, which maybe I'm wrong, is that it seems as though what we're doing here is more of a target plan and apply, in which case the other resources are ignored, which I suppose is how you're able to get such fast responses in terms of your plans and applies. But of course, I may be completely off the mark here, but that's what it seems like is happening now. Now, my question is, if that is true, if that is what's happening, what do we do about, or what do you guys do about drift detection? Do you handle that as like a separate thing, or as in like maybe like a separate run to detect drift that happens, on a schedule, or how is that detected, I guess?
Yeah, so our recommendation, so you are correct. We do refresh on the actual resources in the entire subgraph involved in your change. So there is refresh going on, but they're only restricted to that subgraph. But we recommend generally that you should do drift detection maybe once a day or once a week. And that is a complete run like any sort of drift detection would be. But for the most part, we think that drift doesn't happen like significantly within a 24-hour period, and that generally doesn't impact the entire subgraph in a meaningful way. So I know some people aren't as locked down as others, but if you're in like a pretty like good IAC flow, generally we think that's a fine trade-off to make. Now you can also, we do have escape hatches inside Stategraph. So you can always say like, look, I'm making this change. I know that the subgraph there doesn't cover all the resources that I think I actually want to incorporate in this run. And you can force different resources to actually be run and their associated subgraph as well. So you always have the option to come out and say like, I actually know better which things that I think need to be run in this case.
Nice. Okay, cool. That answers my thank you. This is really cool. Thank you.
Thank you very much. Thank you, Anton. So I don't see any more questions, and we're at the end of the time, so I don't want to hold people up. So thank you everyone for joining. We really appreciate it. And hopefully we'll see you at the next demo day. So everyone have a great evening and see you later.